Okay, so are we good to start? Excellent. Hello everyone, my name's Anna, if you don't know me. And today I'm just going to give you a bit of a rundown of building robots using Node.js. So this is just going to be a really quick intro. Usually at CampJS we have like a whole half-day NodeBots workshop, but I didn't want to risk taking a bunch of robots in my suitcase this time because of the whole airport situation. So if you want to actually get your hands on some hardware and build robots, just look for the NodeBots group in your local area. So there's one based here in Melbourne anyway, CCHS. There's one in Brisbane, and there's one in Sydney. Talk to Damon to find out details, and I'm sure that there are others in other locations as well that I'm not aware of. So the kind of robots that we're talking about here, well, robots are autonomous systems that sense and respond to the world. So that's a very loose definition. And the kinds of robots that I'm talking about are really simple robots that do very little of actual use. We're not talking about the Mars rover here. So an example of one, just pull one out of my pocket, is like this, for example. So it actually doesn't even move. It's just one that I've built that reminds me to do my exercise, and I can kind of hit it on the head. It triggers a button so that it records when I've done that exercise. So it's kind of there to trigger me to change my behavior. So it could be something as simple as this. It's sensing whether I've done something and it's responding by reminding me. Or it could be something that drives around and does something. So kind of the basic parts that you have in most robotics projects, or the ones that I'm talking about anyway, you've got some kind of chassis or, like for example here, a 3D printed shell that all of the parts attach to. You've got some kind of power, whether it's batteries or whether it's running off a very long USB cable, which is what we've done at some NodeBots sessions. And then the stuff in the middle, which is kind of the stuff we'll talk about today. You've got the sensors. These are your inputs. They are the things that sense things that are happening in the world. So for a robot that sort of drives around and detects obstacles, it might be something like an ultrasonic sensor. For this thing, it might be something like a position or a PIR sensor to detect when I'm moving, so it knows to remind me. You've got some kind of brain or control, so typically this will be a microcontroller or a single board computer like a Raspberry Pi. And then you've got your outputs or your actuators. So these are things that do something. They cause some effect in the world. So there might be the motors that make the robot drive around, or they might be lights or screens or something like that. Now, we're interested in JavaScript, obviously. It's kind of becoming more popular for building, especially hobbyist projects like this. And there are a lot of different options out there. So this is just some of the ones that I know about. I'm sure there are others. Johnny 5 is the one that I'll be talking about today. It's the one that I've been involved with. But we've done stuff with Esprino.js in the past. So Esprino is like a very cut down JavaScript runtime that runs on microcontrollers. Tessel, which also is...
Apparently the PowerBoard doesn't like Tessel.
That's a good sign. So Tessel works with Johnny 5, and it also, they had their own platform. It's tied into a particular hardware platform. Particle.io is another example of a hardware platform. So they've got things like the Photon and the Electron boards that you can program using a JavaScript SDK. Cylon.js, which kind of is a project that takes the best bits of all the other projects and kind of pulls them all in together under a single umbrella, sometimes without attribution. So just be aware that they haven't done all of that work, but they have done a good job at integrating it all and documenting it. JavaScript, Mu.js, duct tape. All of these are kind of very small versions of JavaScript designed to be embeddable. So I'm just going to talk about Johnny 5 today, but if you're interested in this field, definitely go check out those projects. So one of the reasons why I like Johnny 5 is because it works with lots and lots of different platforms. So when you're selecting hardware for a project, it really depends on the requirements of your project. So these days there are so many of these development boards and kits available for all different price ranges and lots of different features. So something like a Raspberry Pi, so I've got a Raspberry Pi 0W here, which is a kind of single board computer, so it's got quite a lot of memory, it's got quite a lot of expandable flash for storing programs and applications. So It's very powerful, and you could build quite a powerful robot with this, but it's obviously a little bit more expensive than, say, a $2 microcontroller. So, if I'm running a class for 50 school children and they're likely to destroy these things by plugging power in backwards and that sort of thing, then I'm more likely to use microcontrollers because they're almost disposable. Johnny 5 runs on all of these different platforms. So Arduinos, which are microcontrollers, Raspberry Pis, Teslas, BeagleBones, which are also like a single board computer like a Raspberry Pi, the particle boards, and many others, which you can see the icons for. And if you go to the Johnny 5 website, you can get lots more detail about all these individual platforms. And the cool thing is that the way that it works is that the API is standardized across all of these, so you can write some code that works with, say, a motor or a button or an LED. And then if you decide that you need to upgrade to a different platform because perhaps you've started building on an Arduino and now you want some kind of network connectivity and you want some more powerful number crunching of your sensor data, you want to go to a Raspberry Pi, you can move that code straight across and just plug in an I/O plugin for Johnny 5 and it will just keep working regardless of the fact that you've changed platforms. So yeah, Johnny 5, it's open source robotics framework for Node.js. There's been about, 75 or 80 people who've contributed to this project, including a number of people locally. And every year we have this big event called International Nodebots Day. We've been doing that for about the last 5 years, where we all get together, a bunch of people in the community, and build Nodebots. Unfortunately, we had to miss it in Brisbane this year. It was a couple of weeks ago because we were busy getting ready for Camp.js. But we will have it a bit later in the year. So Johnny 5 was originally designed to work with Arduino, and it communicates with the Arduinos over a protocol called Fermata. So it's over a serial connection, so you plug in, say, over USB or over Bluetooth, and your microcontroller, your robot with the microcontroller is kind of like a really dumb device. It just responds to commands, and you're running a Node.js program on your laptop or maybe on a Raspberry Pi or some other device. It's doing all the smarts, and it's communicating with that peripheral microcontroller, and it's controlling the pins that control the sensors and the actuators, or read from the sensors and control the actuators. So yeah, that Fermata protocol is supported on a number of different devices, and it's not just for Node.js, incidentally. So there are Python libraries that support Fermata. There are Ruby bindings, I think, as well. So if you're into other languages, you can use that same protocol. With Johnny 5, originally it just used Fermata, and it was primarily for microcontrollers. But then through this idea of I/O plugins, which pretty much take the Johnny 5 API and implement it using whatever local GPI capabilities are on other platforms, like Raspberry Pi, you can run it on board. So originally it was designed to have a kind of a primary computer running Node and then your peripheral microcontroller, but now what you can do is run Node on your device, like your Raspberry Pi or BeagleBone, talking directly to its own Johnny 5 instance. So I'm just going to step through how you would get set up using a Raspberry Pi Zero W, because Raspberry Pi is a pretty popular platform. A lot of people have them sort of hanging around at home, so if you're looking for something cool to do with a Raspberry Pi, this is something that you could do. So Raspberry Pi Zero W is interesting because it doesn't have an Ethernet port. It's just got Wi-Fi built in, which means that a lot of the guides that you find online for setting up a Raspberry Pi don't work really well with the Raspberry Pi Zero, and it always just tells you to go and plug into a keyboard and a monitor and that. But you don't actually need that to get set up. Because I don't know about you, but I only have a laptop. I don't actually have an external keyboard and a monitor to plug into. So for a long time, I didn't use Raspberry Pi for that reason. But what you do is you install Raspbian, and pretty much the Raspberry Pi Zero uses a micro SD card, which you can see sticking out the top here. So what you do is you plug that into your laptop, and you pretty much copy that Raspbian image onto the SD card. And then instead of having to plug into the Raspberry Pi, boot it up and configure it, there's a little trick here, which is not particularly well documented, but you create a file on the boot partition of your micro SD card, call it wpa-supplicant.conf, and put in your details. So if you were here, you had a Raspberry Pi here, you could just put in the SSID Camp.js and the password, more coffee, and it would be on the network here. And then if you want to enable SSH access so that you can just SSH into your Raspberry Pi, simply add a file called SSH, so just use touch or something, it doesn't need any contents. Put it on that boot partition of your micro SD card, and then once you put that card into your Raspberry Pi and boot it up, it will be on the network and you can connect to it. And you ask, well, how do I know how to connect to it? What's its IP address? The cool thing is that it's running MDNS, so you could connect using the hostname.locals. So if everybody did this, I guess it would be difficult because they'd all have the same hostname. But I guess you can configure that as well in the configuration files on the SD card. So yeah, you just connect like that. And by default, the password is Raspberry. Obviously, please change this as soon as you get your device set up so that everyone's not able to connect into your device. So if you're using just the default Raspbian distribution on Raspberry Pi, it comes with Node.js installed, as well as a couple of other cool things like Node-RED that we'll talk about in a minute. If you're running something else, or if you want the absolute latest version and the one that's bundled isn't what you want, then you can just use your regular Linux, apt-get, so on, to install Node and npm. And then once you've got that, you've got a little Linux computer, so you can use npm to install Node packages just like you normally would. So the ones that we're using are Johnny 5 and Raspberry Pi IO, Raspi.io. And also they will install the serial port npm package. I've just got that there because it takes a long time to build. So if you're doing this if you're going somewhere, you probably want to install that in advance because it will take a while. All right. So the Raspberry Pi device, it's a single board computer. I don't know how well you can see this, but that bit there is the Raspberry Pi 0W. And you can see it's got a whole row of pins along the side there. So these are your GPIO pins, your general purpose input-output pins. There are 40 of them on the Raspberry Pi 0W, and they're compatible with the pins that you find on other Raspberry Pi modules, like the Raspberry Pi 3 has the same sort of pin layout. So to the side there you can see what all the different pins are. So this is where you plug in all your peripheral sensors and actuators and so on. One of the things that, if you're coming from the world of Arduino, is different here is that it's 3.3 volt logic rather than 5 volt logic. So when you're plugging in say if you have a sensor, if it is generating 5 volts, you might want to use something like a voltage divider just to step that amount of voltage down to 3.3 so that you get the full range of values on the Raspberry Pi. If that doesn't make sense to you, don't worry. That's just a detail for people who already use Arduino. And the pins in Johnny 5 are labelled in a bit of a weird way. So you can see on the side there, they've all got numbers. So from the top, you've got pin 1 and then pin 2 all the way down to pin 40 down at the bottom. Now in Johnny 5, the way that they label them is P1 dash and then the pin number. So P1 is corresponding to the header number because some other Raspberry Pis have more than one pin header. Raspberry Pi 0 only has one, so it's always P1 dash and then the pin number. There's a couple of other ways too. You can identify them using the GPIO number directly, but most of the examples you'll find online will use P1 dash and then the number. All right, so getting started. I'm going to assume that some people here haven't done much electronics, so one of the ways that I like to get started is by using a breadboard, a solderless breadboard, to prototype my circuits. So this yellow thing here is an example of a solderless breadboard. It's a little one, like the one that you see on the side there. You can get bigger ones like this one here that have power rails along the side. You can get even bigger ones than that. And the way that these are designed is on the inside they've got these little metal kind of clips underneath that when you plug your wires into the holes, they just grip onto those wires so that you can connect them all together instead of having to solder wires together. So it makes it very fast to plug your components in and out and change your circuit around. So if you wanted to attach an LED, a light emitting diode, so this is one of those very brightly, little bright lights, you would simply plug that into the breadboard, and then what you need to do is connect your jumper wires. So jumper wires are these wires here, and they've typically got little pins on the ends. From the pins on the Raspberry Pi, across to the LED. And you'll notice that on the breadboard there, you can see there's a resistor, which is that little stripy component in the middle there. So resistor introduces some resistance into the circuit. It's really there to limit the current that's going through the LED so that it doesn't burn really brightly and eventually burn out. So what we've got here is the pins on the Raspberry Pi. So if we go back and look at that diagram there, we're connecting to GPIO 7 and we're connecting to ground. So that's the fourth one down on the left-hand side and the third one down, I think, on the... Oh no, hang on, GPIO 4 is what we're connected to, sorry, and ground. So I've got one jumper wire going across to the LED and the other one going across to ground. So if I want to write a program to control that LED using Johnny 5, I simply create a JavaScript file. So I might call it something like blink.js if I say I'm blinking some LEDs. And because I'm using a Raspberry Pi, I would create that on the Raspberry Pi. Or I'd create it on my computer and then I'd copy it across to the Raspberry Pi. But it needs to be on the Raspberry Pi eventually. And it needs to be in the same place where you've installed your NPM modules. So maybe you've created a little folder project somewhere on your Raspberry Pi. It's just JavaScript, so you can edit using whatever JavaScript editor you like to use. So if you're doing it on the Pi, you might want to use Nano or VI or Emacs or something like that. If you're doing it on your machine, Atom or Sublime or whatever. In your program, pretty much every Johnny 5 program that you write for Raspberry Pi will have this at the start. So you need to require both the Johnny 5 library and the Raspberry Pi I/O plugin for Raspberry Pi. And then what we do is we set up a board object, which is an instance of the Johnny 5 board class. And because we're doing it for Raspberry Pi, we give it this I/O configuration option, which is a new Raspi plugin. So you'll see that at the front of every Raspberry Pi Johnny 5 program. Once you've done that, then pretty much all of the action happens in the event handler for the board on ready event. So this is the same object that we just set up as an instance of the board class. And when it's ready, we can run code to set up our LEDs or sensors or whatever other things that we're working with. So for an example, if we were working with this LED that we've just plugged in, inside that onReady event, we'd have something like this. We'd have a variable LED, which is a new LED object, and we give it the pin number that LED is on. So if I'm using GPIO 4, that's pin number 7 on pin header number 1 on the Raspberry Pi. Hope you're following. So that would be LED P1-7. And then once you've got that object, you can then do stuff to it. So you can, depending on what type of object it is, this is an LED, so there's Johnny 5 API for the LED types of objects. And one of the functions that it supports is strobing, which is flashing. And you give it a number of milliseconds, and it will flash every 1,000 milliseconds or every second. So you could change that to whatever you wanted for different behavior. So let's just do a quick demo of that. Okay, so this is the folder that I've created on my Raspberry Pi. So I've already SSH'd into my Raspberry Pi. And in this folder, I've created a couple of JavaScript files, which are my programs that I'm going to show you. So Blink is the first one. So, uh-oh, something's happened. I've lost my connection. No. Let me just check. Berry Pi. No, that's going to be bad for demos. All right, well, we might come back to that in a minute and see if that works in a couple of minutes. Oh, there we go. Oh, hang on, that might not be my Raspberry Pi. No? Yes? All right, so we've got, we've got some network. We've got the program just there. So I'm just going to run that. Oh, come on, please don't drop out. Good. So the way that you run that is using just Node, like you normally would run a Node program. Let me zoom in a bit more. Again, everyone see that okay? And then you just go node.blink.js. But because GPIO requires root level privileges, you have to add your user to the group, or I'll just do it using sudo. Don't do this at home, that's bad, but yeah. And then it runs. And I don't know if you can see this, but there is a little LED on here that is blinking right now. The magic of JavaScript. Cool. And you'll see there's a little prompt there. This is what's called the REPL, the read eval print loop. And it's just like the Node prompt. You can type stuff in. So I'll show you in a minute how I set this up. But I've got this variable in my REPL that I can use to control this LED. So I could tell it, let me pull that up a bit further so you can see it in the middle of the screen. I could tell it stop blinking, and it stopped. You probably can't see that, but yeah, it stopped. And then I can do things like LED on, and it turns on, or LED off, and it turns off. And you'll see it's printing out a whole bunch of state. That's not an error, that's normally what it does. It's just so you can see what the result of that operation was. So that's how you run these on the Raspberry Pi. Zoom out again, and back to here. Cool. All right, so that was the whole program. It was the first bit that we saw, setting up the libraries, requiring them, the onReady event, and then inside of that, the stuff that we actually want to do with the LEDs, which is setting up and strobing. Now, when you're building a robot, you probably want more than a single LED. You're going to want some sensors, and you're going to want some outputs, so actuators. And there are lots and lots of different components available that are out there. So some examples, you've got environmental sensors that can sense things like the temperature, the humidity, the amount of smoke in the air, the amount of ozone, you name it. Magnetic sensors like Hall effect sensors that you find on things like 3D printers to detect when you get to the end of an axis. Light sensors like photoresistors that can detect the amount of ambient light, or the ones that you have that you face downwards and you blink an LED at the same time as detecting the light bounces back. You can detect whether you're on a black line or a white surface, so you can use line following programs. Sound, so microphones that can detect the presence of sound. They can't actually recognize the words or anything. Piezos that you can use for detecting vibration or the presence of sound. Things like accelerometers, gyroscopes, tilt switches, buttons, etc. So that's just a few examples of some of the components that you'll typically find if you get sort of a getting started robotics kit or electronics kit. And same thing with outputs on your robot. You've typically got things like LEDs, LCD screens to display state about what's going on with your robot, sound like buzzers. Movement obviously is probably one of the more important things with the robot. Most people think of a robot as something that moves around. So you've got your motors that drive the wheels or the tracks. You've got things like solenoids if you're talking about industrial robots in particular. And relays for controlling things, controlling power, so switching the lamps on and off in your home, that sort of thing. So that's just a few examples of some different output components that you might find in your average getting started to electronics kit. And one thing that's important to note with these is that there's this idea of digital and analog sensors and components. So digital, when we say digital, we're talking about digits 0 or 1, so things that are off or on. So in the case of a sensor, it might be something like a button. It's pressed or it's not pressed. It's never kind of half pressed. But you can also have outputs that are digital. So an LED, for example, you can blink it all the way on, all the way off, and just treat it like it's on or off. Or you can treat it like an analog component. So this is where you've got values in between. So for sensors, this is things where, like, an analog sensor, like a temperature sensor, where you're getting a reading. And it's typically, the raw reading will be something like between 0 and 255, or between 0 and 1023, depending on the number of bits that your sensor supports. And for outputs, it'll be things like fading in LED, the brightness. Yeah, so we looked at the REPL. And yeah, so button is a really good example of a digital input. So with Johnny 5, so this, when I show you this code, it's all what goes inside the on ready event. So with the button, you've got the button class, and you've got event handlers. So on down and on up, and you can do different things. So with your LED, you might want to turn it on when you press the button, or turn it off when you press the button. So this is an example of setting up those event handlers to control the behavior. Something like servo motors, common in a lot of robotics projects for like moving things around. Sometimes you can get continuous rotation ones that control wheels. Again, you set it up using a Johnny 5 servo object. So the API supports a lot of different common components, as you can see, on a pin, so pin 35. You can put it in your REPL if you want to be able to control it interactively. And some of the things that you might want to do, you might want to sweep the servo back and forth. You might want to stop it, you might want to center it. You can also set the position of the servo. And servos work using pulse width modulation. So it's this idea of having values in between 1 and 0, but on a digital pin rather than on an analog pin. So it's kind of like simulating voltages in between 0 and 5 volts, or 0 and 3.3 volts. Piezo also works with these sort of values in between 1 and 0. So with the piezo, it's pretty much just controlling the tone that you hear from the buzzer. So those beeps that you get, they can be high-pitched, they can be low-pitched. And the same thing with motors. So motors, you actually usually use a separate motor controller. So this is a circuit for a Raspberry Pi with a motor controller and 2 DC motors attached. So these are really common in those budget robotics kits you get from China. So this would be the code that you'd use to control those 2 motors. So you've got your, using the motor class in Johnny 5, you set it up on the pins. And in this case, because your controller actually has 2 wires for each side, one which is controlling the direction and one which is controlling the speed, then you set those 2 up. And you can see the thing that I've got in there about inverting the PWM, that's just an example. I probably don't have time to go into that. This is an example of how you can control the motors. And you can find out lots more from the Johnny 5 API documentation. All right, so really quickly, you can write all this code from scratch yourself, and you can just run the node programs directly. But one thing that's really cool if you want to be able to integrate with other systems, other components, is using Node-RED. I don't know if Chris talked about Node-RED at all, but Node-RED is this awesome UI that supports a whole bunch of NPM packages, and it is installed on Raspberry Pi by default. So let me just pull it up really quickly, just so you can see what it looks like. So you've got an interface where you've got a whole palette of different nodes that you can drop in. This is an example of a program I've got on my Raspberry Pi that reads from some sensors, and then it's actually using the Node-RED modules that talk to HomeKit, which is the Apple automation sort of framework. So I can get it on my phone, and I can hit a button, and it will actually talk directly to those sensors that are hooked up to my Raspberry Pi, or get readings from them and display them on my phone, all using the magic of Node-RED, which I don't have time to go into right now. But very, very cool stuff, and I highly recommend that you check it out. I have a video all about that that's on the IBM Developer Works blog. So if you're really interested in that project, you can follow that video. All right, so that's pretty much how to get started with robotics in JavaScript using Johnny 5. Oops. If you want to find out more, my blog, I sometimes sporadically post projects there, so you can check out some of the things that I'm building on crafty.com. Johnny5.io is the main library website for Johnny 5, so lots of examples there. I also have a website called Node.ARDX where I've got some Johnny 5 examples that are tailored for Arduino, particularly for the getting started kits that you get from places like JCar. Yeah, it's for Arduino, so if you're interested in Raspberry Pi, I just recommend that you use the Johnny 5 website. So that was a super quick introduction to JavaScript robotics. So if anyone has any questions, I'm around, happy to answer questions. And if you've got some hardware you want to play with, happy to help. Thank you.